Assalamu alaikum students. As you all know that in previous lecture we have studied about series and parallel circuits. Now to our today's topic is almost same topic. In this topic we just place resistors, different number of resistors in series and parallel. Now if we connect these different resistors in series and parallel, what will be their properties? That will we discuss in this today's lecture. So let's start our today's lecture. Resistances in series and parallel. In this lecture I have made a simple comparison between series circuits in which resistances are connected and similarly a parallel circuit in which resistances are connected. So let's first point is almost same which we studied earlier in previous lecture, that in series connection these resistors are connected end to end. If we look at this diagram, this shows that all three resistors are connected end to end, means end of first resistor is connected to the starting end of second resistor. Similarly, ending of second resistor is connected with the end of with the starting of third resistor. Similarly, if we see the connection of resistors in parallel, so in this connection resistors connected side by side as shown in this figure, that all three resistors are connected side by sides, means their one sides are connected together and other sides are also connected together. So we can call this connection as a parallel connection because all these resistors are connected side by side. So second point, as we have studied earlier, that in series circuit current remains the same due to the single loop because there is only one path, so current throughout the circuit will remain the same. Similarly, in parallel circuit voltage remains same throughout the circuit because there are number of paths for the current to flow. So we say that in parallel circuit voltage remains same throughout the circuit. Third point is voltage in series circuit. If we connect resistors in series, then voltage will divide across each resistor. Similarly, in parallel circuit current divides in each path according to the resistances. In series circuit voltage drop across R1, similarly voltage drop across R2, similarly voltage drop across R3. If all these three resistors are having same values, then the voltage drop across each resistor will remain same. Similarly, in parallel circuit, because there are number of paths for current to flow, so we can say that current divide in each path depending upon the value of these resistors connected in parallel. If all these three resistors have same resistance value, then same current will flow through these three paths. If they have different resistances values, then current which will flow these three paths will be different. So in series circuit, if you have to find equivalent resistance, then its formula will be equal to R equivalent will be R1 plus R2 plus R3. Similarly, if we have to find equivalent resistance in parallel circuit, then its formula will become 1 over R equivalent is equal to 1 over R. Just I have to make a little bit changing in this because there is here it will be R1. So okay, now it's okay. So in parallel circuit equivalent resistance will be equal to 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now it's the formula to find equivalent resistance or total resistance in parallel circuit. Equivalent resistance will also be called as the total resistance. Next point is voltage drop across. So if we want to find out voltage drop across each resistor in series circuit, then we have to use these formulas according which are derived by Ohm's law. So voltage drop across R1 will be equal to V1 is equal to I into R1. Similarly, voltage drop across this resistor R2 will be equal to I into R2. Similarly, voltage drop across resistor R3 will be equal to V3 is equal to I into R3. Now you can see that here in these three formulas I remains same, because we already studied that in series circuit current always remains the same due to the single loop or single circuit. Now if we have to find total current, then this formula will be used. I is equal to Vs means supply voltage over Req means equivalent resistance. So this will be the formula to find the total circuit current in the series circuit. Now if we add these three voltages drops across the all resistors which are connected in series, then its sum will be equal to the supply voltage. So we can say that supply voltage will be equal to voltage drop across R1 which is equal to V1 plus voltage drop across R2 which is V2, and similarly we add also voltage drop V3 which is voltage drop across R3. So all algebraic sum of these all voltage drops will be equal to the supply voltage. Now if we have to find, because we know that in parallel circuit current will have to divide through each path, so current flowing through this path, we can also say that current flows through R1 will be equal to I1 is equal to V over R. Sorry, here is also R1, so I have to make a little bit changing. So now it's okay. So current through resistor R1 will be equal to I1 is equal to V over R1. Similarly, if we have to find current which is flowing through R2 will be equal to I2 is equal to V over R2. Similarly, current flowing through R3 will be equal to I3 is equal to V over R3. So by using these three formulas we can calculate the current flowing through each path in parallel circuit. Now these formulas are also derived from Ohm's law. Here as we know that voltage in parallel circuit always remains the same, so we place V and V, so this will be equal to the supply voltage. And if we have to find out supply voltage, this formula will be used. IT means total current multiply equivalent resistance. Now if we calculate all these three path currents, then their algebraic sum will be equal to the total supply current. So we can say that IT is equal to I1 plus I2 plus I3. So these are some important points regarding if we connect resistors in series and parallel. Now we solve simple problems which are related with series and parallel circuit. So here is first problem which is regarding series circuit. Here a circuit is given in which two resistors having value R1 is equal to 5 ohm and second resistor R2 whose value is 15 ohm. These two resistors are connected in series to a 12 volt battery, and we are saying we have to say that calculate these three values. First one is total resistance, second one is total current, and third one is voltage drop across each resistor. Simple circuit diagram of this problem is shown here, in which two resistors having values 5 ohm and 15 ohm are connected in series with a voltage source of 12 volt. So first of all, we have to find total resistance. Now we know that in series circuit we can find out total or equivalent resistance by just simple adding these resistors which are connected in series. So total resistance or equivalent resistance will be equal to R1 plus R2. Now just put the values. R1 is equal to 5 ohm plus R2 is equal to 15 ohm. That result will be 20 ohm. So we can say that total resistance will be equal to the 20 ohm. Now we have to find total current which is flowing into this circuit. So we know that in series circuit current always remains the same. So we can, and here voltage provided, and we have also find total resistance which is equal to the 20 ohm. Now by just using Ohm's law we can easily find total current which is equal to I is equal to V over R. Just put the values. V 12 volt over R which is 20 ohm, so total current will be equal to 0.6 ampere. Now we have also find voltage drop across each resistor, which will become voltage drop across resistor R1. We can say that it will be equal to V1, and voltage drop resistor R2, this will be equal to V2. So just we have to use formulas which I mentioned in my today's lecture, which will be equal to V1 is equal to I into R1. So I is 0.6 ampere and R1 is 5 ohm. Just multiply these two quantities, we get 3 volt. So we can say that voltage drop across resistor R1 will be equal to 3 volt. Similarly, we have to find voltage drop across R2. This will be equal to V2 is equal to I multiply R2. Just put the value 0.6 ampere multiplied 15 ohm, that will be equal to 9 volt. So these are the two voltage drops which are occurring across resistor R1 and resistor R2. Now if we add up these two voltage drops, this will be equal to the total voltage supply. So total supply voltage, so just add up these two voltages, 3 plus 9, we get 12 volt, which is equal to the supply voltage or battery voltage, which is also 12 volt. So this is the problem regarding the series circuit. Now we find out another now here another problem which is regarding parallel circuit. So if we look at the question here, we also two resistors are given. R1 having value 10 ohm and R2 having value also 10 ohm are connected in parallel to a 20 volt battery. Calculate the equivalent resistance, total current, and current flowing through each resistor I1 and I2. So here we have also find out three different quantities. First one is equivalent resistance or total resistance, second is total current, and third one is current flowing in each path. Current flowing through R1, also current flowing through R2. So total, if we find out total equivalent resistance, then we know that in parallel circuit total resistance or equivalent resistance can be find out by using this formula. 1 over R total is equal to 1 over R1 plus 1 over R2. Now just put the values. 1 over R total is equal to 1 over 10 plus 1 over 10. If we find LCM, that will be equal to 10, or simplify this by using LCM, then it will be equal to 2 over 10. Now here we have to find total resistance, so we reciprocate inverse it, that will be equal to R total. Similarly, this quantity will also be reversed because we have to find total resistance, so we have to reverse this quantity. If we reverse this, this will also be reverse. So R total is equal to 10 over 2. So if we divide 10 by 2, it will be equal to the 5 ohm. Now second, we have to find total current which is flowing through the parallel circuit. So similarly, we used Ohm's law. Total current will be equal to V over R. Total supply voltage is 20. Total resistance is 5 ohm. So total current will be equal to the 4 ohm. Similarly, we have also find current through flowing through each resistor I1 and I2. So again, by using Ohm's law, we can also find current flowing through each path, and we also know that voltage in parallel circuit always remains the same. So I1 is equal to V over R1. So just put the values. V is 20, R1 is 10, so we get 2 ampere current. Similarly, if we want to find current flowing through the resistor R2, it will be equal to I2 is equal to V over R2. So just put the values 20 over 10, it will also be equal to 2 ampere. Now if we add up these two currents I1 and I2, 2 plus 2, it will be equal to the total supply current, which is equal to 4 ampere. So these were the simple problems relating series and parallel circuit. In next lecture, we also discuss some more problems regarding some more complex problems regarding these series and parallel circuits. So up to now, you have to watch these lectures again and again. If you find any confusion or difficulty, you may ask me through comment section. So take care yourself, and also I'm repeating our same request. Please like and subscribe my channel DAE Electrical Knowledge Space 04, so that you easily get more interesting videos. Thank you.